Hi everyone, welcome to Chapter 21. Another physiology chapter, circulatory system, respiratory system, urinary tract system, and the nervous system. Body rebuilding. Could engineered human tissues, brought to life in the lab, replace failing organs in people? Let's find out, shall we? Standing over the operating table, covered head to toe in teal scrubs, physician Jerry Lawson lifts a long white tube out of a bath of clear liquid. Carefully, slowly, he threads the tube through the unconscious patient's upper arm and stitches each side of the tube to an exposed blood vessel. Bioengineer Laura Nicholson stands to the side of the operating table, watching closely. She and Lawson created the tube being implanted in the patient. Once the operation is complete, Lawson steps back, and Nicholson gives him a hug. "Congratulations to you," says Nicholson happily. "We're saving the world." What are they doing? It was a bioengineered blood vessel. On June 5th, 2013, Lawson, Nicholson, and their team transplanted a laboratory-grown blood vessel into a human. It was the first such procedure in the United States and a major feat for the field of tissue engineering. The effort to grow or regenerate tissues or organs using engineering materials and principles. Other engineered tissues implanted into humans have included nerve grafts, bladders, and windpipes, also known as trachea. Lawson and Nicholson imagine a future in which any type of organs can be constructed in the lab. In an ideal world, we'll be able to grow all sorts of tissues for patients, so a surgeon can literally reach up on a shelf, pull down a tissue graft, and implant it in a patient, Nicholson said in 2013, shortly after the first blood vessel transplant. That's really going to be a revolution, being able to grow replacement parts for patients that they don't have to wait for. Because organ shortage is a major concern in healthcare. According to the U.S. government, the number of people waiting for an organ would fill a football stadium twice. And every day, an average of 18 people die waiting for transplants of kidneys, hearts, livers, lungs, and more. As a matter of fact, in my extended family, polycystic kidney disease is a genetic dominant disorder. I have multiple family members that have received kidney transplants. It sometimes takes years and years to find a matched donor. Tissue engineering would totally revolutionize the field of organ transplantation and save many lives. In many cases, stem cells are used. And this is just a little video clip showing how we can produce beating heart cells through stem cell technology. So here we go. Here's cells that were not originally cardiac cells, either embryonic stem cells or induced pluripotent stem cells, and they can actually be grown in culture and beat like a heart. And so as you can see here, the contractions of this tissue is growing hearts in the lab. And there you have it. That's your teaser for today. Thanks so much for listening. I will see you guys soon.